we'll now alter the configuration so that we can split the users to domains. Currently, all users will accept messages to any destination defined by the MyDestination parameter. So the user linuxcbtsuzy1 will receive messages to anything that's specified by MyDestination, including my host name, localhost, my domain, which includes the following: linuxcbtsuzy1 at linuxcbtsuzyserve1, which is the name of the box, .linuxcbt.internal. Also, linuxcbtsuzy1 at localhost, and also linuxcbtsuzy1 at linuxcbt.internal, since my domain is defined. So these are the various ways. And we're missing one that we've yet to mention, which is, or we have mentioned, which is linuxcbtsuzy1 at IP address 192.168.1.30. So these are the various ways messages can come in, and this applies to also the user Dean. Now, we've purposely set up two separate users to be able to illustrate at some point virtual alias maps. We're pretending that our system's hosting messages for an ISP where you need to split the domains, and as a result, what we need to do is set up the virtual alias maps. So that's what we're going to attempt to do now. Let's clear this, and we're going to modify the main.cf file. So let's take a look at main.cf. And towards the end, we're going to include the directives for the virtual alias maps. So let's navigate all the way to the bottom. And we're going to define these as, and we'll just place a comment in here which says added virtual alias map support. And we'll specify a date, which is fine. And there are two key directives that are required to enable this to work. One is actually called virtual alias domains. That's where we enumerate the domains that we're going to support. The other is called virtual alias maps. So we need two domains to make this particular model work. So we have to do both of them. So let's specify virtual alias domains. And we're going to append or use a domain that's currently not being routed to the system. Our system, again, is handling linuxcbt.internal, as well as a subdomain which maps to the host, as well as localhost, as well as the IP address. So let's specify linuxcbt.external as our first virtual alias domain. Next, we'll specify the map file, virtual alias maps. And we're going to set this equal to a type, a database type that's recognized by the current postfix implementation, followed by its path and name, which is usually etc postfix and the name of the file. In this case, we'll use the file virtual. The type, as you know, isn't explicitly type or literally type. It's of the type hash, which is the default type supported with Berkeley DB libraries that are included with your Linux distribution. If you don't have it installed, you should, because so much of what postfix is able to do is based on looking up information in these defined maps, including the ability to map these virtual alias domains. Great, so we have the domain specified, we have the map specified. What we want to now do is save this file, and we're going to work on the map file that we've yet to define. So let's define that file. The default postfix installation actually provides a virtual database file, a virtual text file that can be mapped out using the postmap command. However, we're going to define an entirely new file. If we ls in this directory, you don't see a virtual text file which contains the key value pairs. So we'll define one, and the format is similar to the other files that we've defined thus far, including the transport file, which was recently defined. There's a left side and a right-hand side, or two columns. So it's a table, it's a matrix. Well, nano, virtual. Now, there is no hard set rule which says that the file must be called virtual. So when you consult the postfix documentation, you will see virtual mentioned, but we're doing it for consistency so that regardless of the source that you consult for postfix information, it's consistent. You can call the file anything you want as long as you instruct postfix to query it for the purpose of virtual alias maps. You should be okay. So on the left-hand side, we're going to define the actual email address that we'd like to map, and on the right-hand side, we'll map to a local account or a remote account. So let's place some comments in here. We have the left-hand side, which is equivalent to email address, etc. We'll say etc. because we can specify variations upon email address, including catch-all addresses, which we'll show you shortly. And on the right-hand side, you'll specify local and or remote addresses, because you can actually alias, like with the aliases file, to multiple addresses if you separate them using a delimiter such as comma. Now any line again that begins with the hash mark will of course be ignored and not processed, not included in the database that gets generated by PostMap. Part of the reason of using PostMap to generate the Berkeley DB file is to clean up any superfluous entries such as hash marks. So our first entry will specify the user linuxcbt suzy1, since that's the first non-root user we created, at linuxcbt.external. And on the right-hand side, which is separated by one or more tabs, we'll specify the local account that this particular user's address should be routed to. So we'll simply send the messages to the account linuxcbt suzy1. So we're simply just providing a map here. Also, let's specify a map for the user Dean at linuxcbt.external. And we'll separate the right-hand side by a tab, and this user's email will be routed into the local Linux mailbox account, Linux account for the user Dean, which is considered a mailbox account. That's where messages will be routed to for this particular user. So we have two entries in. Let's save the file, and we'll need to use PostMap to generate a virtual DB file. After doing so, echo the exit status. You can see that it was returned successfully. We now have a virtual.db file. In fact, a file against virtual DB will return the fact that it's a Berkeley hash. Great. We also have the directives programmed into the main.cf file. So a postfix reload will reinitialize postfix's configuration, its running configuration, which now means that a postconf grep virtual underscore alias underscore will reveal that we're currently handling an alias domain of linuxcbt.external, and we're using a maps file or a maps directive which points to a file of type hash to etc postfix virtual. So we're now ready to service this domain, and once we've shown you how to service this domain, we'll add additional domains. Of course, DNS needs to be properly set up, so dig linuxcbt.external and query the mail exchanger to ensure that messages will be routed to our system regardless of the host that's used, providing they use, of course, the same DNS servers or DNS servers that gain answers from the source which reveals SUSYServe1 as the mail exchanger. Again, just ensure that your name resolution's intact. If not, ensure that you set up a transport mapping on the systems, or a transport map on the system that you'd like to have send messages to this particular system. Now in a separate window, we'll compose a new message. This is on linuxcbt work 1. We have this already set up, and this new message is going to the user linuxcbt suzy1 at linuxcbt.external, which is our first virtual domain. Again, the virtual domain could also be treated as a local domain, but the advantage to defining your domains as virtual domains is that you have the flexibility of routing messages using the virtual file to both local and or remote recipients. So with the virtual file, we can send messages destined to the left-hand side to multiple right-hand side entries, including local and remote. Whereas with the aliases file, the message is already considered to be local. So when messages are routed using normal aliases, postfix has already deemed the message to be a message that belongs to a user who has a mailbox on the local system. With virtual aliases, your postfix instance can simply be a pass-through server which perhaps provides some sort of screening and filtering of the messages before forwarding it to its final destination or to the next hop. So that's the real difference between virtual aliases and normal aliases. With virtual aliases, you don't need to maintain the mailboxes on the pass-through server. But in our case, the mails terminate here. But we have enough systems to illustrate either case. Great, so we want to send the message to linuxcbtsuzy1 at linuxcbt.external, and that's what we'll do. We'll say testing virtual alias maps, and the body will include, we'll say, the difference, the major difference between normal aliases and virtual aliases is that virtual aliases can map between addresses that do not terminate on the pass-through system. And that's important. Now let's send this message, and the message is gone, it hasn't bounced. On the SUSY Enterprise box, we'll tail varlog mail, and we'll look for evidence of the message being passed through our system. Let's search through, and we'll compare to the current time, 11:59, from root at linuxcbt work1, and the message was sent originally to linuxcbtsuzy1 at linuxcbt.external, but it got mapped out to the same username at linuxcbt.internal. So it was delivered to the mailbox locally. That was a local mapping. The vacation program then responded to the message, because we still have that in place. That means the user linuxcbtsuzy1 has the vacation program set up in the forward file. But nonetheless, as the user linuxcbtsuzy1, we can confirm that the message was delivered. Again, we're logged in as such a user. Let's launch MUT, and there's a new message, testing virtual alias maps. But because the vacation program is in place, an automatic response was sent to the sender, root at linuxcbtwork1.linuxcbt.internal. Great, so that message has gone to that user, but we did get the mail that we sent to the user with the termination point of .external. While we're at it, let's compose another message, and we'll send it to dean at linuxcbt.external. Testing virtual alias maps. No body is required. We'll send it, and that was also sent. Again, we can examine the contents of the log file, and the message was actually delivered to the user dean at linuxcbt.internal, which is considered local. It was originally sent to the same user at external, but it was delivered. Now in shell number 4, we're logged in as the user dean, so let's simply run the MUT application to receive the message. There it is, testing virtual alias maps with no body. Great, so the messages are being routed, and this tells us that the way we've defined our virtual file is consistent with the way that Postfix processes the virtual file. It's based again on a two-dimensional mapping, a matrix of left-hand side, right-hand side, rows and columns, and each row corresponds to one left-hand side followed by one or more right-hand side records. Next, what we'll do is expand on this idea by adding additional domains, which will mimic, or at least in our minds mimic, being in an ISP environment where one system is functioning as perhaps a pass-through or a destination termination for multiple domains. We'll test out additional domains that we'll make up arbitrarily, and then we'll also test out mapping non-local recipients to non-local recipients. So we'll essentially function truly as a pass-through server.